The content is reviewed by a professional engineer and researchers to ensure factual accuracy. In 2022, NASA's asteroid impact mission successfully smashed a spacecraft into an asteroid named Dimorphos, and the world breathed a sigh of relief. We diverted the asteroid's course successfully as our planetary defense plan. But on January 8, 2026, a groundbreaking study from the University of Oxford just turned that security into a nightmare. It turns out, we've been preparing for the wrong kind of rock. If a solid iron asteroid, like the massive 16 Psyche, headed for Earth today, our best weapons wouldn't just fail. They might actually make the asteroid stronger. NASA's mighty proton beams will fail to blast it due to metal's ability to distribute and absorb heat, and even our atmospheric friction will not be enough to shatter this monster. NASA's DART mission hit what scientists call a rubble-pile. Think of it like a giant space sandcastle. It's easy to nudge because it's loose, but space is hiding a much more dangerous predator, solid iron asteroids. These are the remains of dead planets. They aren't loose rocks. They are single, massive blocks of crystalline metal. And according to Oxford's new data, hitting them with a spacecraft is like firing a BB gun at a tank. Because iron is nearly 4 times denser than normal space rock. A solid iron asteroid just 1 mile wide carries enough kinetic energy to flatten an entire continent. If we try to nudge it using our current technology, the iron core would simply swallow the impact energy and stay on its collision course. We wouldn't be stopping an impact. We'd just be ringing a very loud, very deadly bell exposing the Earth to 24 million megatons of TNT, 1,600 times the explosive power of the largest nuclear bomb ever detonated. Historically, Earth has witnessed devastating impacts, such as the Chicxulub event 66 million years ago, caused by a 10 to 15 kilometer carbonaceous asteroid that led to the dinosaur extinction. However, iron impacts, though less frequent overall, are uniquely destructive because of their higher density and energy release. Consider Arizona's Meteor Crater, also known as Barringer Crater, formed about 50,000 years ago by a mere 50-meter iron meteorite traveling at 12 to 20 kilometers per second, which created a perfectly circular 1.2 kilometer wide and 170-meter deep crater, ejecting an astonishing 5 million tons of material. If the same event repeats, massive fireballs would ignite widespread global firestorms across continents, while towering ejectoplumes would blanket vast landmasses, turning day into an apocalyptic twilight, shrouded in darkness and ash. If it struck the ocean, which has a 60% probability, colossal tsunamis hundreds of meters high would propagate across the seas, flooding coastal regions hundreds of kilometers inland and devastating densely populated areas worldwide. On a global scale, thick dust clouds would block 50 to 80% of sunlight for years, causing temperatures to plummet by 5 to 10 degrees Celsius, halting photosynthesis in plants, and triggering widespread mass famine and ecological collapse. The new Oxford model accurately matches 92% of 25 young terrestrial craters, as well as the observed iron meteorite flux, providing a far more reliable and validated assessment of impact frequencies and risks. Fortunately, humanity is not without defenses against such threats. NASA's DART mission in 2022 successfully altered the orbit of the asteroid Dimorphos by 32 minutes, proving the efficacy of kinetic impactors for planetary defense. This mission validated deflection techniques even for iron targets, although their exceptional strength and density mean that stronger impacts would be required to effectively redirect larger metallic threats approaching Earth. Future missions like NASA's ENEO Surveyor, launching in 2028, will employ infrared detection technology, which is far superior for identifying metallic asteroids that optical surveys often miss. We aren't defenseless, but we need a new generation of planetary weapons. We can't rely on kinetic impactors anymore. We need to think bigger, maybe nuclear deflection or even gravity tractors. Hit that subscribe button and join me at Science Ed, because the more we know about what's coming, the better chance we have of stopping it.